All right, folks, thanks for waiting. It's about 11:03, 3 minutes past the hour here on Mountain Time, and I think we can go ahead and get started. Just a real quick, let me go ahead and just unshare my screen real quick just to make sure that I don't have any complaints as of yet that the audio is not working. I'm hoping everyone can hear me. All right, looks like we are all good. So let me go ahead and reshare our screen then. So thanks again, everyone, for joining for today's live training like we do every Tuesday. For those of you who have not been here before, welcome. We hope that you'll join us every Tuesday for these live training sessions. For those of you who are returners, thanks again for joining us again for today's session. Today we're going to be talking about spatial analytics for intermediate users. So for those of you who are maybe just starting to dabble in spatial analytics or maybe want to learn what it's all about, today's session is going to be perfect for you. We're going to spend some time talking about how to do some very common spatial analytic processes and how you can do those types of things or calculations or applications a couple of different ways in Designer. So you'll be able to kind of see a diversity of approaches for doing some of those common needs in spatial analytics. Before we jump into today's content, I'll go ahead and introduce myself. My name is Christine Bonthias, and I'm an instructional designer here at Alteryx. I work on the community team where we host these live trainings. So just a couple housekeeping items before we jump in is that I want to let everyone know that you are muted. As soon as you join this call, you were automatically placed on mute. That being said, we welcome questions, we welcome interaction, we welcome participation, but we ask that you do so by using the chat feature or the Q&A feature that's part of the WebEx. I'll go ahead and keep an eye on that during the presentation so that way I can address any questions that might come up that are particularly relevant at that time, or at a convenient break, maybe before we dive into the workflow, I can go ahead and answer some questions at those kind of transition times. So go ahead and use that function to pose any questions to me, the host, Training Services, directly, or you can make that question public. We are scheduled today for about an hour. We'll probably plan on about 45 or so minutes of content. We'll see how we do. And then we'll spend some time at the end where we'll just take a bunch of Q&A. So if you want to save your questions till the end, you're more than welcome to do so too. I'm happy to stay on the line and answer some of those questions that come up. We are recording today's session as well. Again, another reason why our participants are on mute for sound quality. But what that means is that when the session is done today, give us another day or two to render this session, and we will post the playback as well as the workflows and the inputs that we're going to use as we build today's workflow. We'll post all that back onto the community, onto the post where you were able to get the link to join today's call. So that way if you ever want to revisit this or you have a friend who wasn't able to make it today, just go ahead and point them there where they'll be able to access this recording in the future. All right, so let's go ahead and get started. So to just kick off so we know kind of where we're going, where we're headed for today's session, we are going to start with some upcoming trainings, just give a brief overview of what's on the calendar, what's coming up for the rest of this month, as well as give some information on our community. We're going to dive into some background about the workflow we're going to be doing, specifically about some of the spatial tools that we're going to be using today. Then we're going to go ahead and jump into Designer, where we'll go ahead and build out a workflow, and then we'll talk about at the end some resources you have for support. So if you haven't been on our community site, community.alteryx.com, I highly encourage you to do so. More likely than not, you probably have been on our community just to get the links and get some information for today's session. But if you haven't explored everything that the community has to offer you, I highly encourage you to click around. It's a great place to browse some discussion forums where you can either search for questions that you may have or post your own questions if you're running into a problem and you want to test out the knowledge of the community to help you. We highly encourage you to just peruse. It's always good to get some tips and tricks from the community as well. You can browse knowledge base articles if you're looking for more in-depth information, or maybe you're looking for some inspiration of what else you can do with Alteryx. We have a great Alteryx use case matrix that's there. It's a great place to network. A lot of friendships are made over our community. Some good fun in the weekly challenge over there. or discussion forums. And if you haven't, you want to catch up with somebody maybe you met at Inspire a few weeks ago, it's a great place to find them online. If you have any ideas for our community, maybe a feature request that you think would be really neat, we love to hear those. There's an area on our community to submit those as well as blogs for some nice easy reading when you need a little break, and then if you're into developing your own tools, macros, apps, or maybe using our SDKs, there's a whole developer community that's devoted to topics just like that. So there's a wealth of resources, a wealth of information. If you haven't, if you've just barely scratched the surface, we highly encourage you to get involved and learn more. My favorite place, and hopefully yours too, on the community is our Alteryx Academy. It's a place for all things learning, and chances are you've already visited here because this is exactly where we host all of our live trainings. Live trainings we host every Tuesday at just this same time slot, 11 o'clock Mountain, so 10 p.m. Pacific, for those of you who are on the West Coast. We also record all of our live trainings that we do every week, and we put them on the community. We post them there for you, and currently we just launched this really neat index that's part of a live training site, so you can go ahead and search that index for maybe a live training that is particularly relevant to you or something that you are trying to learn. So that's brand new, and I hope you find that helpful. We also host a variety of interactive lessons, which if you haven't checked out for today's session in particular, there's a whole course on spatial analytics. So if there's any topic that we cover today, the chances are there's an interactive lesson to help guide you through that. So it's a great way to try some activities, test your knowledge. They're a blend of videos and fun activities and little quizzes that you can do to learn new concepts without even needing Designer, which is pretty neat. We also host every week a weekly challenge. This week is particularly exciting. If you were at Inspire this week, potentially you were able to join us for that Grand Prix. So today, or yesterday, Monday, we posted the first lap. So you can go ahead and give it a try on your own. You can try it with the timed limitation, so 12 minutes. You can try it in front of peers. You can try it just on your own. Take your time, but that's really cool. So you have a chance to see exactly what those contestants up on stage had a chance to do in front of 3,000 people. We're going to post all 3 laps. So yesterday was the first one. So we're going to post the second and the third lap here in the coming weeks. But in addition, there's another fun index there, so you can try out, especially some of these spatial concepts that we're going to look at today. We have a variety of weekly challenges that also touch on some spatial tools, so you can also test out and challenge yourself to learn more there on Weekly Challenge. And then finally, product certification. If you're not already course certified, I highly encourage you to do so. It's something fun to work towards. Spatial analytics is something that's actually covered on our advanced exam. So for some of you who may be preparing for that, this is a great session to join and just get a heads up as to what types of tools and what types of questions you may be asked about on that certification exam. All of these pages, all this information you can find at academy.alteryx.com. Speaking of live trainings, we are currently building out our calendar for August, so stay tuned there. You'll see a lot of to be determined. But let's talk about what's going on in July. So here we are, July 17th. Today's topic, Spatial Analytics for Intermediate Users. Next week is going to be super exciting. It is a brand new session that is geared towards those of you who are preparing for your advanced certification exam. It's going to be an advanced certification prep session hosted by our certification program manager, Elizabeth Bonnell. So join us next week. That's sure to be a very exciting one. And of course, as always, we will record it, so you'll be able to access it if you're not able to join us next week. And then finally, end of the month here, July 31st, we're going to be doing a session on Alteryx Gallery and best practices. So more for your gallery end users, maybe more towards the beginning level, just to kind of give you a gauge as to the scope of that session. And then stay tuned for August sessions as we continue to build those out. All right, so let's dive into our content here. Let's talk a little bit about this workflow that we are going to be building today. So just to kind of a basic and just kind of get all ourselves on the same foot, why spatial analytics? For those of you who already see the value, I mean, I am preaching to the choir here, but for those of you who are potentially maybe newer to spatial analytics, let's just talk about why you might want to continue in this vein. Well, first of all, everything that happens somewhere. And that geographic component of understanding patterns or understanding different phenomena may be really important in helping you derive some really powerful powerful insights based on locational relationships that exist in your data. Spatial analysis is really interesting in that sometimes when you visualize something on a map or a nice graphic, you can see or understand patterns that maybe you wouldn't catch quite as easily with just numeric or text data that's coming in a YXDB file. It really does help you discover and then communicate some of these more important findings visually. So it's kind of a neat way to really enhance some of these analyses that you may already be doing. So let's talk about our use case today. We're going to talk about a use case that is fairly local to those of us here in Colorado. So for those of you in the potentially Denver area, this may sound a little familiar, but the city of Erie in Colorado wants to understand the extent of the oil and gas presence in the community. So a few of their goals include is identifying the oil and gas facilities that exist within the city limits of Erie. Then they want to determine some of the city or the coverage of the city that is within a certain distance from an oil and gas facility. And then they want to determine the closest oil and gas facilities to each school site that exists in the community. So pretty common, you can see we're looking at what oil and gas facilities are within a spatial object. We're maybe going to be looking at distance for the closest oil and gas facilities to each site. And then we're also going to be working with coverages. So how do we expand or contract the extent of some of our spatial objects? And these are the tools that we're going to be using to do so. We're going to be talking about some of these may seem a little familiar for those of you who are already somewhat versed in spatial analyses. But I'm hoping that you'll pick up something new from some of these processes. What we're really going to be focusing on today is taking some of these very common processes like matching spatial objects based on spatial relationships, expanding or contracting the extent of spatial objects, and also the really basic ones that people want to do with spatial analyses. What is it all about? It's about calculating distance. How far is something else? And identifying the nearest objects. We have a couple different ways that we can do these in Designer. And so we're going to be really focusing on that today. What are the different methods we have for doing some of these calculations using some of these tools? So for expanding the extent of spatial objects, we're going to be looking at the trade area tool and the buffer tool. Buffer tool doesn't get talked about nearly enough in my opinion, and I think it's a really neat feature that we can use to modify the areal extent of the spatial objects. We're also going to be talking about the distance and the find nearest tool, kind of in conjunction about how those either can work together and why you might choose one approach over the other. And the same for the spatial match and the spatial process tools. You know, very similar kind of calculations or analyses that can be done, but some of these different tools might be better suited for analyses of the structure of your data. And that's really going to be the focus of today's session is why might you pick one approach over the other, and maybe what are the subtle differences between each of these tools. So let's go ahead and get started. We're just going to go ahead and run through some of these tools just to kind of get some familiar setting and some familiar information on these tools before we actually jump into Designer. But a lot of these things that we're going to be talking about with each of these tools, we're really going to hit home on when we jump into the workflow. So if something is not clear at this point, it will probably become more clear as we actually work with the tool in Designer. So let's talk first about the spatial match tool. When we talk about the spatial match tool, we're almost talking about a join. We're joining data based on a spatial relationship. And in fact, if you look at the spatial match tool configuration on the right-hand side, that bottom half of the tool might look really familiar to you. It might actually remind you of the join tool itself. Yes, they both have these embedded select windows, and they both have two inputs. In the spatial match tool, we have these two inputs that come in, two input anchors, one for your target spatial object and another for your universe spatial object. So this is how you're telling data to join to each other, essentially. But instead of matching on the same fields, you're joining or you're matching based on a spatial relationship, where you specify how a target spatial input interacts with another spatial input, your universe. How does it relate or how does it match to that universe input? We'll cover some of those interaction types on the next slide, but just like the join tool, we have multiple outputs that come of it. We have two. We have the matched output records, so the spatial records or the records from those data sets that met that criteria of having that spatial relationship. Yes, yes, it exists. That's the M anchor. And we also have the unmatched records, where that spatial relationship that we specified does not exist. So what are these different spatial relationships that we can use to join data together? Well, we're always going to be talking about how a target relates to a universe. So that can really kind of depend what you are looking for, especially when we start talking about contains or within. So if you can see, if a target intersects a universe, typically this is with point to polygon or polygon to polygon, but it's where target actually shares overlap, where they have common area. We can also define the match based on where the target contains a universe. We can also say where the target is within a universe. So essentially the contains and the within in this statement are basically opposites of each other, so you can see that. So it's really important to be familiar when you're defining these relationships, is understanding, one, what you're looking for, and two, the geometry of the spatial objects that you're working with. Because you want to know if a spatial object contains a universe, hopefully that universe is not bigger than your target. Hopefully you have those set the correct way. We can also say that a target touches a universe, so it's just where they touch the boundary, not intersect. That's another common misconception that I see people use, is that touching is not necessarily intersecting. So if you want to make sure that you're actually capturing the overlap area, then you want to make sure that they intersect. You can also specify a relationship where a target intersects or touches. That's the most liberal of the two, where you're going to be able to capture the most records, where they intersect or they even just touch. And then finally, probably least commonly used, but you might find a way to use it, is that a bounding rectangle of the target overlaps the bounding rectangle of the universe. Again, not very commonly used, but you may have a particular use for it. So just like we have a spatial match tool, another tool that can be used to do some very similar processing to this is the spatial process tool. Now, where are these two different? So just like the spatial match tool has two input anchors, the real limitation here of the spatial process tool for performing these spatial interactions is that you're limited to one input anchor, which means that the one record that you want to relate to a second has to be in the same record. That will become more clear as we work through the workflow, but that is a very significant limitation because it can require really huge appends, particularly, that can just blow your data out of the water. So you want to be careful. Sometimes this may be a better fit for your data than others, and we'll talk about that as we build out our workflow. But we can do very similar actions in terms of spatial relationships and applying those different spatial processes. We can combine objects together, we can cut objects, and we can create intersections or the inverse of intersections. So let's talk a little bit about what those actions look like. When we combine objects, let's take a look at our original spatial object. We have a blue square and a yellow square, some of which overlap. When we say we want to combine these spatial objects, we're essentially putting them all together. We're saying add spatial object 1 plus spatial object number 2 to output the combination of those two spatial objects. We can cut the first from the second, and we can cut the second from the first. So they're basically just inverses of each other, but you can see there in the bottom in the little green rectangles, you can see how cutting the first from second and cutting the second from first yields different results, basically with the order. So just like with the spatial match, how we have to relate a target to a universe, the spatial process tool always relates spatial object 1 to spatial object 2. And you have to be very careful about which one that you're relating to the other. You can also create the intersection object and conversely, the inverse intersection object. The intersection object is the area at which those two overlap. So you can see that's just that small corner of the top left corner of the yellow rectangle or the bottom right corner of the blue rectangle. That's actually the intersection. And then the inverse intersection is everything but. So everything except the areas where these two overlap. So now let's talk about what tools we have for modifying the areal extent of spatial objects. The first and probably most commonly used, in fact, I'm sure most of you on this call, if you've done spatial analyses before, have probably used the trade area tool. But we're talking about this and how do we extend the spatial object of a point spatial object. So how do we create this circular area around a point that is a defined radius? You can see in the trade area tool configuration here at the top, this spatial object field of point source. That is the significant limitation here of the trade area tool, is that we really do need to have a point spatial object in order to create another trade area polygon spatial object around. We can set the value or multiple values for a radius, so we can create, and which we'll do this in the workflow, but we can either create just one output spatial object, so one fixed object, say with a radius of 15 miles. We can create donuts or something like bullseyes, where we can create multiple spatial objects, like a radius of 1, another one with a radius of 3, another one with a radius of 5. We'll take a look at the syntax of that. We can also create what's called donuts, really, is what I've heard people call them, where are polygons that represent ranges of distance, so between 3 and 5 miles away from a specific spatial object. And then finally, we can choose the units in which we create this radius. So we can define this radius as 15 miles, 15 kilometers, or if you have this third-party data package, even as 15 drive time minutes from a particular point spatial object. So you may be wondering, and for those of you who may have done spatial analyses with other softwares, you might be looking to do this very similar idea of creating a trade area, but around either a line or a polygon spatial object. For that, we use the buffer tool. The buffer tool allows you to create or expand or even contract the specific buffer size around either a line or a polygon spatial object. Now, based on the input kind of spatial field that you put into this tool, whether that's a line or a polygon, you have different ways you can work with this. For a line, because it's only one dimensional, you can only measure length and there's no actual area associated with a line spatial object, you can only expand around. So you can say, okay, buffer this line by 1 mile or so on every side of this line, which will create a polygon. Now with a polygon, you can actually expand by doing the same thing. So around this polygon, let's expand it by, buffer it by 1 mile on every side, buffer it by 5 miles on every side, or you can even contract it. So by using a negative value, you can actually say, make this polygon smaller, detract it by, cut it off by 1 mile around from every border. So unlike the trade area tool, however, this is one limitation, and never fear, I already put in a feature request for this, is that this buffer tool does not support the syntax to create multiple buffers at a time. So we'll talk about that a little bit in the tool once we see how the trade area tool can create those multiple trade areas at a time. We'll take a look at how the buffer does not do the same type of thing. So if you're looking to create maybe a polygon buffered by 1 mile and 3 miles and 5 miles, that will require 3 different buffer tools, not necessarily the one tool with a different syntax. Finally, in spatial analysis, probably the most common thing you want to know is what is the closest thing to me, whether by calculating distance or by finding the nearest object. So the find nearest object, we'll talk about this in conjunction with the distance tool. The find nearest object has 2 input anchors. It can accept a target and a universe, and it compares these two based on certain criteria that you, the user, impose, whether that's based on distance, so how far away can these possible objects be to be quote-unquote nearest, and how many do I want to find. So in a way, the find nearest tool is like combining a distance tool and a filter tool with a sample tool. It's really kind of neat. We'll walk through this as we build out the workflow. But the inputs with the target and the universe will then give you 2 different outputs. So the matched records, which do meet the criteria that you've imposed as to how many nearest points to find and is it within the maximum distance. And then finally we have the unmatched records, the U anchor, which says these do not meet the criteria that you've imposed. A couple of things, configuration options that I think are really neat is that you can select the number of nearest objects to identify. So the question asks you in the Find Nearest Tool configuration on the right, how many nearest points do you want to find? And you have complete control to say, I only want to find one, the single nearest object to find, or maybe I want to find the 10 nearest objects. That is completely up to you. And you can specify the maximum distance at which an object is nearest. So if that is within 5 miles of a certain location, or if that's within a half a mile of a certain location, this is where you can impose that kind of maximum distance in which to actually find a nearest object. One advantage that the Find Nearest tool has over your kind of more traditional distance calculation is that the Find Nearest tool, in addition to outputting just sheer distance in terms of miles maybe or whatever unit you specify, but it actually will output two additional columns as well. One is your output rank. So one is the closest, 2 is the second closest, 3 is the third closest. So it actually will rank and sort those for you, which you can use as a usable field down the line. And it also outputs cardinal directions, so west, east, northeast, whatever it might be, which can be used. I've seen people use these in really interesting ways. You have the Find Nearest tool, which does some of the same things as the Distance tool. And again, just like the Spatial Match tool and the Spatial Process tool, really the big difference with the Find Nearest tool and the Distance tool is 2 input anchors versus 1 input anchor. So with the Distance tool, instead of having a target and a universe, you only have 1 input anchor, which means the 2 spatial objects that you want to calculate the distance between must be present in the same record. So again, you might have to find yourself doing a little bit of data manipulation or some data transformation to make the structure of your data actually accommodate the needs of the Distance tool. Distance tool has some neat features though, in that not only does it output distance, but you can actually output the cardinal direction and the output direction in degrees. And it also allows you to understand distance in a couple different ways, especially when you have a point to polygon calculation going on. When a point is within a polygon, so imagine, a store maybe within a city boundary, is that this store could be closest to the city, it could be outside the polygon, or it could be within the polygon. And so we have a couple different ways to return that distance and represent the distance when something is within something else. This is kind of unique to the Distance tool and can be used in many different ways as well. We'll talk a little bit about this as we build out our workflow, which we are just getting started right now. So now that we've covered some of the fundamentals of these different tools and how you might use these different tools, let's go ahead and transfer on over to Designer. And while we do that, I'm going to go ahead and unshare my screen here, and I'll take a look and see if we have any questions that have come in on the WebEx. So while I get that set up, just give me a moment here, and I'll see if there's anything I can answer. So it looks like one question has come in, are we supposed to have a workflow or a data set yet? No, not at this point. We will post it after the workflow or after today's session, so you can have to build out at that point in time. But for right now, we're just going to do kind of a watch and learn type situation. So let me go ahead and get set up here. And excuse us, we're on a little bit of a different setup today, so please excuse any clunkiness as we make these transitions. All right, so let me go ahead and make sure I've got my input set up here. And reshare my screen. All right, so everyone should be seeing Alteryx Designer at this point with a couple of different input tools here on the canvas. So let me go ahead and bring all these up so they're a little bit more visible, and we'll talk through about what's in each of these and what we're going to do with them. With spatial analyses, it's really important if you have spatial data or spatial objects in your inputs that if you actually want to see the spatial objects associated with those in the Browse Tools configuration window, that you actually have to have a browse tool. You don't get in a nice little data preview of your spatial objects. So with spatial objects, make sure that you have your browse tools so that way you'll be able to see what you're working with. So let's take a look at a few of these different inputs. The first input that we have, like we've mentioned before, just to kind of give a refresher about what we're doing, is that we want to understand the presence of the oil and gas facilities within the city boundary of Erie, Colorado. So the first input that we have is actually a polygon spatial object that represents the city boundary of the city of Erie. And we'll see if this renders. Hopefully it does. But really all it is just that municipal boundary. Nothing too fancy there. The next one that we have is a file of oil and gas locations within Colorado. So you can see here we have a ton of different facilities here in Colorado, and associated with those are point spatial objects as well as some other information about those different drill sites like locations and their status and things like that, their location IDs, which we won't really end up using. What we really want to know is where these particular facilities are located. So we have these as point spatial objects. These are oil and gas, maybe facility or locations. We also have our oil and gas fields that are present in Colorado. So we can see these scattered all throughout the state. Erie, just for reference, is right about in this area, which is probably where we're going to be capturing some of our data, but we have some polygon spatial objects associated with each of those oil and gas fields in the state of Colorado, as well as some other information such as the formation and the rock formations that these are found in. Again, not to use for us, what's really important here is the actual location of these spatial objects. So let's work on our first objective here, is we want to figure out which oil and gas sites are actually within the city of Erie. And let's just see if this has loaded yet. We'll give this another shot here just so you can kind of, there it goes. Now you can kind of see what we're working with here is basically just the municipal boundary of the city of Erie. So the first thing to figure out is which oil and gas sites are actually within the city of Erie. We're going to go ahead and use from our spatial tool palette here in Designer. First way we're going to approach this problem is by using a spatial match. We're going to use a spatial relationship to join these two spatial objects. And what I like to do with my data insets is I like to treat this spatial match tool just like I would an actual join. And one thing I always do before I join data is I unique my data. So I'm going to do that same thing here. I'm going to throw a unique tool on here from the preparation tool palette, and I'm going to throw it on my oil and gas location because I want to make sure that I'm not joining multiple locations to the city of Erie to find duplicate records potentially. So I'm going to unique my data based on location ID here, which is my unique field for this particular input. And let me just run that real quick. And it's a good thing we did this because, yes, there are a couple of different duplicate IDs in here. So we don't actually need this information. So, whew, that was good. That way we get the most accurate information we can. So let's go back to the spatial match tool. Remember how a spatial match basically relates a target to a universe. One thing that really helps me when I'm doing a spatial match is that one thing I didn't mention in the tool configuration is that remember how we have our two inputs. We have a target and we have a universe. And then we have two outputs. We have the matched records and the unmatched records. So I like to work backwards. The unmatched records will show the unmatched targets in this input. So it will show me whatever unmatched targets will fall out of my join. And for me, what's really important to see that didn't match would be my oil and gas locations. So because I want to see my unmatched oil and gas locations fall out my universe, that automatically tells me that I would want my oil and gas locations to be my target. That's how this kind of, I guess, relationship works here between your unmatched and your matched is I get a lot of questions as to Well, which one is your target and your universe? And for me, what really influences it is what I'd want to see that falls out of my join, essentially, which for me would be those oil and gas locations across the state of Colorado, especially because I only have one input here in my Erie, Colorado input. So I'm going to go ahead and connect my shapefile or my spatial object for Erie, Colorado over to my universe. And now let's go ahead and configure this spatial match tool. So remember that for the spatial match, we're always relating a target to a universe. And first things first is that we have to configure the spatial object field for each input. So just like a join, how you have to specify, unless you're joining by position, of course, but you have to specify which field joins to what. You have to select the spatial object associated with each target. And if you have multiple spatial objects incoming from each of these different anchors, make sure you select the right one. In our case, it's pretty easy. We only have one. So the spatial object field from target will be selected here. And in my universe, since I'm using records from a U input, I'm going to select my spatial object here as well. If I didn't actually want to use an incoming anchor, I have the option here to actually select files from a file or a database. I don't actually have to bring in this file of my universe inputs if I didn't want to. So that's kind of a neat little optional feature that you have, and some people use that to maybe speed up the processing of a workflow because you're not actually reading in all this data that you don't necessarily have to. So there's a little optimization trick there. So remember how we have to always relate a target to a universe. So in this case, we want to know where our oil and gas locations are within the city of Erie. So I'm going to say where my oil and gas locations, my target, is within my universe. Now I have a couple different options here. I could actually say intersects and get the same results. But I think for me, what it helps me is that I want these oil and gas locations, let's say that there's an oil and gas location just on the city boundary, or maybe it spans the boundary a little bit. I want it to just be completely within. I want it to be completely contained within my universe. But this is an option where you have different ways. You may find that different interaction types might give you different results, and that could be wise because now all of a sudden, instead of capturing some that intersect, that just intersect, within the entire universe, you might get a different number of spatial object matches, whereas with intersect, you might get more, and with touches and intersect, you might get even more than that. So it does really kind of depend as to how liberal you really do want to be with defining this relationship. I'm going to be as constrictive as possible, so with my target within my universe. As I mentioned before, here we go. Here's our embedded select window. I'm going to take advantage of this opportunity to kind of just clean up some data, so some things I don't need. I'm just going to go ahead and get rid of a whole bunch of these fields that I'm not going to be using later on. Let's see, options that I'm going to select and deselect all my highlighted fields that I have. And I have these for my target and my universe, right? So you can see here, just like the join tool does, we have the opportunity to take a look at what might be duplicate names, just like the join tool has adds that prefix with right and highlights it pink. It does the same thing here in the spatial match tool. So I'm going to take this opportunity to rename this to say that this is actually going to be, my universe is coming from Erie, so I'm going to call it Erie City Spatial Object to give it a better name here. And let's just take a look at my top one here. I might actually do the same for my target and rename that one too. So I'm going to call it oil, gas, locations, spatial object. And let's go ahead and I'm going to add all browsers here, and I'm going to run this workflow. Great. So let's take a look at what happened. We have two outputs, remember? So we have matched and unmatched. So how we interpret this is that now we have the oil and gas spatial objects, so the oil and gas locations that are actually within the city of Erie. And I actually have both of these spatial objects here now in the same record, so I can see which spatial object matched to my city polygon. And my unmatched records, remember, these are all my unmatched oil and gas locations that did not fall within the city of Erie. So we can see some things down here, you know, where are these things located? You know, they're definitely, some of these are in Cheyenne or in Cheyenne County or in other places in Will County or Rio Blanco County, definitely not in the city of Erie. So it looks correct to me. So we have 277 different oil and gas point locations that are within the city of Erie using the Spatial Match tool. So now let's take a little bit of a different approach. Let's go ahead and move down to another input down here with, remember, our oil and gas fields. And remember that these are polygon spatial objects. So let's do a little bit, let's find the areas of these fields that are within the city of Erie, or that intersect the city of Erie. We're going to do this using a different approach. In fact, we're going to use the Spatial Process tool to do this same thing. So I'm going to go ahead and drag this on here, Spatial Process tool, drag this here onto my canvas. Here's this big limitation. Remember that one input anchor. This can be a problem if your data is not set up with each spatial object or these two spatial objects you want to compare in the same record. Right now, they're in two separate inputs. The city of Erie is up here, which is what I want to use, and I also want to use my gas field. So what I have to do is I have to figure out a way to get these in a single record. And to do so, I'm going to use an append tool. When using the distance tool or the spatial process tool, you'll usually find that this append tool comes in handy. However, this can be one big drawback of using the spatial process tool or even the distance tool, is that you might have to append a lot of different records to a lot of different records, which can just blow your data up like exponentially. So sometimes it's really not the best option. However, because we have one tool here or one input here, just one polygon that we're going to be appending to about 1,400 other polygons, I think we're going to be in good shape. We won't impact our processing too much. So here we go. Here's our targets, and I'm going to go ahead and take the opportunity here as well in this select window to get rid of some of these, whoops, what did I do? Get rid of some of these fields that we're not necessarily going to use. So a lot of these formations, things like that, that aren't necessarily important to us. So again, I'm going to select all those and deselect my highlighted fields here. So I just have my city name and my city spatial object, and then coming in with some of my gas fields and some information as well as the spatial object there. I'm going to go ahead and rename this in my append tool to be, I'm just going to call it fields spatial object, just to keep it nice and clean. One thing to be aware of in the append tool is this error on appends is more than 16 records. To be safe, especially if I know what I'm doing and I've planned this out, I'm going to allow all appends just so I don't run into an error message here. So let me just connect this just so we can take a look at what this data actually looks like now coming out of this append tool and why this was an important part of our process. So now we can see that the city of Erie, our target, has been appended to every source. So this polygon for the city of Erie is now on the same line as every oil and gas field. This is how we're going to be able to stream our data in one single data stream here into the Spatial Process tool. Now in the Spatial Process tool, let's go ahead and start configuring this. So 1 and 2. So we're going to talk about, let's see, a spatial object field and field spatial object. Now, does it really matter which one is number 1 and which one is number 2? Well, the answer is no. But your action can be important, or it's important to understand which action you want to apply and which spatial object is defined as number 1 and number 2, especially when you're cutting. In this case, we just want to see the areas of these oil fields that are within the city of Erie. So we actually just want to see the intersection objects. We want to see the areas of overlap for each of those objects. So I'm going to go ahead and add my browse after and rerun this workflow. So it will do this spatial interaction, the spatial process, it will try and intersect each of these two spatial objects. And as you can see, there's a lot of nulls, which in our case is kind of a good thing. It means there's not a lot of oil and gas fields in the city of Erie. However, to be sure we're actually seeing everything we hope we're seeing, I'm going to add a filter. And I'm going to filter out everything that is not null. We're the spatial object process column. Uh-oh, come on. Doesn't want to seem to let me. Oh, my filter tool is not behaving. Let me try and add that on again. Give that one more try. If it doesn't work, we will move on. Seems like WebEx is not playing nicely with my filter tool. Well, that is okay. We'll go ahead and add a browse here, and we'll go ahead and run this again. The reason I'm going to add a browse so we can rerun this again is to actually prove that there were a couple records that actually did come out with areas in the city of Erie. So we can see that we actually do have a couple of records here in the spatial object process that actually came out as not null. There actually are a few areas here in the city of Erie where we actually do have some overlapping area of oil and gas fields. So I just want to point that out for you. One thing to note is that you'll see that this column with my spatial object process, which is either null or has a polygon spatial object in it, there's one right there, is called spatial object process, which is not a very helpful name. So what I think you'll find quite a bit when you're doing spatial analyses is that you're going to be relying on a lot of select tools to change some of your names. So I'm going to call this gas oil field intersection. Fantastic. So because I see we're running a little bit short on time here, I'm going to go ahead and skip to a particular process for calculating distance, which is going to be another comparison between how do you do this with the 2 input anchors versus how do you do this with 1 input anchor. So again, we're going to be using the find nearest tool and then the distance tool. And what the application we're going to be using for this is to calculate how far away some of these gas and oil field locations might be from some of our schools in Erie. So let me go ahead and copy on another input data set here and drag it onto our canvas. So let me go ahead and drop this on here. You'll see one more input showing up. We have some Erie schools. So let me go ahead and add a browse on here so we can see what we're looking at. So within the city of Erie, we have 31 different school locations, which we are representing as points. So we want to know which gas sites, first, which gas sites are closest to these schools. That might be a concern for some people, and we want to understand how these gas areas and oil facilities are distributed amongst our schools. So the first approach we're going to do is, again, just like we did the spatial match tool, let's go ahead and use the two-pronged approach, which is using the find nearest tool. This helps us identify the nearest object to another. And remember, how we're going to phrase this question is, which gas sites are closest to our schools? And you'll notice we have a target and a universe, and I'll tell you here what helps me with understanding what goes where. I think of my question. I like to phrase this or think about these things in terms of knowns and unknowns. What do I know? Well, I know the locations of my schools because my question is which gas sites are closest to my schools. So I know the locations of my schools, and my known locations are going to be my targets. My unknowns, which are going to be here for my universe, are things that I don't know. I don't know which gas fields are located closest to my schools. So that really helps me determine which input goes to which input anchor. So that being said, my known here are the locations of my school. So I'm going to connect that to my target input. What I don't know are these gas and oil locations within the city of Erie. Which gas locations or facilities are closest to my school? So I'm going to go ahead and connect that up to my universe input here. Now I'm going to go ahead and configure my find nearest tool. So just like with the spatial match tool, you have to tell which spatial object from each input is going to be used for your target and your universe. A very similar process here to your spatial object tool. So I'm going to use, let's see how this one has two spatial objects that are available. It's really important to pick the correct one. The one that we want to use are actually the points, so the oil and gas spatial objects. Now this is where we have a lot of control as to what counts as nearest and how many nearest objects do we want to find. In this case, let's just find 3. I want to find the 3 nearest gas and oil facilities to each different school. Now I could set this to 1, I could set this to 10, doesn't really matter, but for me 3 seems like a pretty good number. In terms of maximum distance, this is essentially how far away something counts as nearest before it's not. And I'm going to go ahead and set this to half a mile, because for schools, I don't think, let's hope that they're not within half a mile, but let's find out, shall we? So I'll go ahead and set my maximum distance here. I can either use this drop-down menu by a number, or I can manually type in a value, which I did to get 0.5. Then I'm going to set my unit to miles. You have kilometers as well as drive time if you have that third-party data set, but we're just going to use standard miles for today. Couple neat things here. So again, you have this embedded select tool window, which gives you the ability to rename columns or deselect columns, but it also tells you about a couple different columns that will also be output here with your data. One is that find nearest rank, so which one is first, second, or third closest, which will be a numeric data type, which is great because then you can sort it later down the line if you ever want to. It also outputs the distance. So again, why would you calculate distance with the distance tool when you find nearest can do it too? Well, a couple different reasons, but it's nice to know that it's here. It also does come out of the find nearest tool. As well as direction. This is cardinal direction. So is it to the north? Is it to the east? Is it to the southwest? I'm going to deselect this for now just because it's a field that we're not going to use, but it's kind of interesting that it's there. I'm going to go ahead and add all browses and run the workflow. Let's go ahead and take a look here at what this means. So we had 85 records that came out. So every school, so you'll notice that, again, we had 31 schools come in. We had 85 matched records and 1 unmatched record. So what does this really mean? Well, what this means is we had a lot of different schools match to different numbers of gas sites. So we can see here that each of these different schools, let me scroll back over here, so here's the code 1057, so this is of one school, matched to 3 different gas sites, all of which that are within a half mile of the school's location. So that find nearest rank, 1 is the first closest, 2nd is second closest, and 3 is third closest. If there's ever a tie, let's say that there's a tie for number 1, they're the same distance away from each other, is that this find nearest rank will be a tie. They'll both be reflected as number 1. Now, just because we specified to find 3 for each doesn't mean we're going to get 3 output records for every school. So, for example, this school here, Gibson School, subcode 1100, only matched to 2 locations, only matched to 2 gas or oil facilities that matched our criteria. That was within a half a mile from that school. So, you're not necessarily all to get the number of nearest points that you specified if there's not that number of points within your maximum distance. So kind of interesting thing as to why this number of matched records sometimes can be a little difficult to interpret. And now for that unmatched records. These are your unmatched targets, right? So your unmatched schools. So we have Vista Ridge School 4110 that actually did not match to any gas or oil field location. This is not within, doesn't have any gas or oil field location within a half mile of that school. So now let's do this with a distance tool. Let's find the distance from oil and gas fields to another. And let's actually use this with the distance gas oil fields. So I'm going to go ahead and drag on a distance tool onto Canvas. And again, remember, we only have that one input anchor. Big limitation. So we're going to use the same approach as before. We're going to actually append all of these different schools. So we're going to append our schools to these locations of these oil and gas fields. And hopefully, let's see if I can configure this, this filter. That would be nice, because then we wouldn't be appending 1,407 records. We'd only be appending 2. Oh, it's a bummer. It is not working, but that's okay. We'll continue on. We'll type it in as a custom filter. Maybe it'll let us do that. We'll say is not null with this spatial object field. Ay, ay, ay. This filter tool is not playing nice with WebEx today. Here we go. Let's try this. Here we go. Oil and gas field intersection. We'll do that. Click on, click off, see if it helps. There we go. All right. We'll go ahead and run that, so now we can see how everything hopefully falls in line just as we expect. So 2 records being appended to 31 records means that we have 62 records coming out. So now we can see that each school location has now been appended to every of these, or each of those 2 oil and gas fields that are present within the city of Erie. So now, because we have these in a single record to record level, we can now do this calculation with the distance tool. So let's go ahead and select our spatial objects. We want to find the point or centroid source, so we want to find these schools and how far they are from an oil and gas field, one of these different polygons. Now, one thing that we can do here is output. Of course, we want to output the distance, so we'll leave this box checked. But we have a couple of options here when a point is within a polygon, which is what we're really trying to look at here. We're looking at a point spatial object, so every school, and how it relates to an oil and gas field, which is a polygon. We can interpret these a couple of different ways. Is that when a point is within a polygon, so when a point is within a gas field, when a school is within a gas field in this example, which we hope does not happen, we can just say it's a distance of 0. If it's within something else, it's a distance of 0. Or you can return the distance to the nearest edge, which will output a negative value. So it will output the distance from the point to the nearest edge of that polygon as a negative value. So let's go ahead and do that just so we can kind of see and interpret it that way. If we have the third-party data set, we can output the drive time. And again, similarly, we have some of these other options the Find Nearest tool gave us. We can output the cardinal direction, and we can also output direction in degrees. Again, a kind of a useful thing if you do have a need for it. But what it doesn't do is it doesn't rank your distance. So one thing to be aware of here. We'll output our units in miles, and we'll go ahead and add a browse tool and run this workflow one last time. So let's take a look here. These oil and gas fields, let's go ahead and get rid of some of these, things that we don't necessarily need to see, but we can see where fields might be within some of these, or some of these schools are very close or within some of these gas fields here in the city of Erie. So something to really look into. Let's take a look at what this looks like. We can see that some of these school locations are actually very, very close. You know, they're outside the polygon, so some of them are, you know, not quite a mile away. Some of these are a little over a mile away, about 3 miles away. Whenever you have a distance that's negative, this tells you that it's actually within the polygon. So that's something really interesting to look at, because remember, we could have returned this as a value of 0, or you can actually return the distance to the nearest edge. So these are some values and things that could be very useful to us and could be interpreted in a variety of ways. And see the closest oil and gas schools that would be closest to some of these locations, we have to apply some sorting, some additional sorting, and potentially some additional sampling if we wanted to get maybe like top 10 and closest schools to gas fields or something like that. So let's go ahead and wrap up. I see we are over time by about 3 minutes, which is just about right since we started a couple minutes late. So let's go ahead and talk about some resources you have for support. So in support, so of course we hope you take a look at our community first. Should always be your first stop where you can post your questions if you're running into issues, or search discussion forums. Chances are if you've had a question, someone else has had a very similar question, and if it's potentially there for an answer or hopefully solved on the community. We also have knowledge-based articles where you can get some more in-depth information, and if you have found something out and you want to contribute, you can do the same. So just let us know. Community.alteryx.com is where you can get involved and participate, and we hope to see you on there. For all things learning, especially with some of these topics we talked about today, spatial analytics, Alteryx Academy is a great stop. So this live training session, remember, has been recorded and will be posted back to community. We have a whole set of interactive lessons, a whole course of spatial analytics. So if anything you want to revisit from today's session, there is a lesson there for you on interactive lessons. Weekly challenges have lots of different fun activities and fun exercises you can try your hand at with spatial analytics. So we encourage you to check that out and get involved there. And then, of course, when you're getting ready for your product certification, we have a section there where you can register and take your core exam or your advanced exam or maybe even your expert exam. You can find all that at academy.alteryx.com. And then finally, if you're really running into a problem, find yourself in a bind, can't just get through it, go ahead and contact our support team, support@alteryx.com. They are a fantastic group of people that are willing to help out with pretty much anything you can throw at them. And that's all we have for today. So again, thank you for joining today's session. I know we're over time, but I'll go ahead and stay on the line a few more minutes just to see if there were any questions that came through that I can answer towards the end. Otherwise, we will see you next week for our advanced certification exam prep session, which we are very, very excited about. So have a great Tuesday, everyone, and we'll see you next week.